Welcome to our comprehensive tutorial on implementing mining and consensus algorithms in Java. Today, we'll dive deep into the fascinating world of blockchain technology, breaking it down so you can understand how to build these algorithms yourself. Before we get started, let's clarify a few key concepts. When we talk about mining in blockchain, we refer to the process by which new blocks are created and added to a blockchain. Consensus algorithms ensure that every participant in the network agrees on the current state and the validity of transactions. We will focus on the two most popular consensus algorithms today: proof of work, POW, and proof of stake, POS. We will begin with proof of work. But before jumping into the code, let's visualize how POW works. A miner must solve a cryptographic puzzle. This usually involves finding a nonce that produces a hash lower than a predefined target. Let's conceptualize this algorithm in a simple flow. 1. Get the block header information, including previous hash, timestamp, and the nonce. 2. Hash this data. 3. Check if the hash meets the difficulty requirements. 4. If it does, the block is added to the blockchain. If not, increase the nonce and repeat. Now, let's start with our Java implementation. First, we need to set up a basic structure for our blockchain. We'll define a block class that includes attributes such as index, previous hash, timestamp, and nonce. I'll show you the code now. In the block class, we have a calculate hash method which generates the hash based on the block's data. Notice how we're using a hashutil class to apply SHA-256 hashing. We will create that class next. Let's implement the hashutil class, which contains the method for hashing. We can use Java's built-in message digest for SHA-256. With our block and hashutil classes in place, we can start implementing the mining process. The miner will need to continuously calculate the hash using different nonces until it finds a suitable hash value. Let's define a mineBlock method in our block class, which will perform the mining operation. The method will loop through nonce values, calculate the hash each time, and check if it meets the required target. In the mineBlock method, we keep incrementing the nonce and checking if the hash starts with the required number of zeros, determined by the difficulty level. This is the essence of the proof of work mechanism. Now let's test our mining algorithm. We will create a main class with a simple test to initiate the mining of a block. When you run this code, it should output the hash of our first mine block, and you should see how the nonce is changing until a valid hash is found. This is the basis for proof of work mining. Next, we'll move to proof of stake, which eliminates the need for intense computing power. Instead of miners competing with each other, validators are chosen based on the number of coins they hold and are willing to stake as collateral. In a proof of stake system, new blocks are added based on the stake amount. The more you stake, the higher your chances of being selected to validate the next block. Let's create a basic model for this handling. We will define a validator class. This class will hold the validator's address and the amount of currency they are staking. It will also include a method for selecting validators based on their stake. The select validator method calculates the total stake of all validators and randomly selects one based on their stake amount. This ensures that validators with a higher stake have better odds of being chosen. Finally, let's test our proof of stake implementation. We will simulate adding several validators and selecting a validator for block creation. When you run this main function, it will print out the address of the selected validator based on their stake. This demonstrates how the proof of stake consensus mechanism works in theory. Now that we have implemented both proof of work and proof of stake, you have a solid foundation to understand how blocks get created in a blockchain environment. To summarize, we have built a basic blockchain with a mining algorithm based on proof of work and a consensus mechanism that utilizes proof of stake. We've seen the core components of each algorithm and how they operate in practice. I hope you found this tutorial informative and inspiring. If you have any questions, please leave them in the comments below. Remember, blockchain technology continues to evolve. Stay curious, keep coding, and until next time, happy coding!